Today we are going to study main thing what is the mechanical wave and what are its types, and secondly some properties of wave we will discuss, and we will define some terminologies related to waves. So starting with the first very important thing, when you are sitting in front of a pond or a lake, or you are in front of a pool of water and you are sad and throwing some stones in it, you can see that whenever a stone hits the water, so there is a wave generated that moves outward toward the bank or the shore of that pool. So this is the actually the wave that is generated because of your stone gives the energy to the water. Similarly, when you are on the seaside, you can see there are a lot of tides, a lot of waves coming toward you, and if you are inside the water, you can feel whenever a wave or a tide hits you, so there is a lot of energy, lot of power in it. So this power or this energy is actually transmitted by the air through water, and water is hitting you with that much energy. So what actually the wave is the disturbance that the stone is creating in the water, the stationary water, or wave is the disturbance that is created by the air in the sea water. So the wave is disturbance that is created by some other object, and it transports energy from one point to another point. So whenever we will talk about the wave, we will say that wave is the energy that is transported from one point to another point. As you can see in the water, or you have a rope that is tied from one end and other end is in your hand. You move your hand like left and right, so you will see that this rope has disturbed, so its wave is generated like the movement of the snake. So this wave which your hand is producing, it's actually the disturbance in the rope. So either the disturbance in the water or disturbance in the rope, both disturbances are called waves. So now when we are talking about the waves, what we are actually talking about, we are saying that it is a disturbance in a medium that creates, you can say that that transports energy from one point to another point. If you are able to see the screen, you can see I just wrote the definition. I just wrote deaf here, but deaf doesn't mean deaf. It is just short form of definition. Wave is a disturbance in a medium. It is used to transport energy from one point to another point. Whenever I use the word medium, medium mean it can be air, it can be water, it can be rope, whatever it is. So it is the wave is the disturbance in the medium that is produced in medium because of some external force. Secondly, when we are talking about the types of the wave, so these types are dependent on the medium. So what are those two basic types of the wave? If you are able to see at your screen, there are two basic types of wave. One is called mechanical wave and other is called electromagnetic wave. What is mechanical wave? Mechanical wave is a wave that need a medium to move the particles or to transport the energy. So wave that require medium is called mechanical wave, and the wave that do not require any medium are called electromagnetic wave. Which wave require medium? Like the wave in the water, like the wave in the rope, like the wave which are sound waves. So sound waves are traveling when there is a medium between you and the source. For example, Abdullah is speaking and Abdul Aziz is listening. So what actually happening? Abdullah is transporting the energy in the form of wave through the air. If there is no air, vacuum is there, Abdul Aziz will not listen. If you remember in grade 6 or 7, you might have, or lower grades, you might have observed or talk about an experiment that there is a bell inside the jar, and whenever bell starts ringing, hammer hits the bell and you can listen the voice. But after some time, if you evacuate the air, if you put it on vacuum chamber and air is sucked, as air is removed from the jar, the sound of the bell is reduced until whole of the air is evacuated from the jar. So you will not be able to listen the voice even though the hammer is striking the bell. So what does it mean? It means to listen a sound, we need air as a medium. If there is no air, we cannot listen that sound. So mechanical waves that I am talking about are the waves that require medium for their propagation, for their motion, that require medium, like water waves, rope waves, or sound waves, etc. Okay, but electromagnetic wave do not have any medium for their transportation. This is very tricky thing. Why? Because if there is no medium, how they travel? That really important question. But for an example, light is a form of wave, but that light sun is providing to us, it passes through the space, and it is a vacuum between sun and the earth. Gravity, there is an area that don't have any air, that don't have any gases, that doesn't have anything. So light still passes from that medium. So that no medium. So from the vacuum. So whenever the light is passing through the space, through the vacuum, there we don't have any kind of medium. So these kind of waves, like light waves, are called electromagnetic waves. Similarly, radio waves, you know that from radio station to your house, your radio channel, or the FM, you can see, you can listen from your mobile, or you are moving, traveling in the car, and you are listening the radio. So this radio signal can also pass through mountains, can also pass through any chamber, vacuum, or there is medium or there is no medium. So these kind of signals are also called electromagnetic wave. So now we are on at conclusion. What is a wave? Wave is a disturbance in a medium used to transport energy from one point to another point. These waves can be mechanical or can be electromagnetic. Mechanical require medium like water, like rope, like sound waves. They require medium like air. Some waves do not need any kind of medium like light waves or radio waves. These are called electromagnetic waves. So now we will not talk about electromagnetic waves now, because this is not our topic, but we will discuss inshallah in grade 11. I don't know in second term in which chapter, but it is there. But when we talk about mechanical waves, now we are going to further study mechanical wave. These are also of two types. Uh, Both need medium, so both are mechanical wave. One is called transverse wave, one is called longitudinal wave. The transverse waves are like water wave, rope wave, and longitudinal waves are sound wave. What is difference between them? When you are talking about transverse wave, so transverse waves are the waves like water and rope. I just try to explain it with the form of rope. This is the position of the rope. This is fixed from or tied from this end, and this end is free, and you are holding it. When you are holding it, the left hand, you move your hand up. So what happened? A disturbance, which is called pulse, is created. When your hand goes down, another pulse is created, but it is downward. Particle move, the rope particle move downward. When you move your hand up, rope particle move up. When you move rope down, rope particle move down. But this upward movement of particle moves a little bit forward. So when you will move up again, so this downward will go forward and upward will take its place. So as you have done this one movement, either up or down, it will move forward. If you are continuously moving your hand up and down, so this down, up and down movement or disturbance is flowing forward. So you can say that this wave is moving forward, but the particles of the wave, particles of the medium are just moving up and down. This thing is very interesting, that the rope will not move forward. Only the energy your hand is providing, it will move forward. If you want to understand this thing, I can give you two examples. For example, if you knot this rope at different points, for example at this point, you can see the knotted portion of the rope will just move up and down, but sometimes this knot will be up, sometimes this knot will be at equilibrium position, sometimes this knot will be down, but this knot will not move forward. It will just stay on the up and down motion, but the hump or the dump, the upward or downward portion of the wave will go forward. So if this happens, you can also see this at your home. Fill a tub with the water or a bucket with the water. and pour 2 or 3 pieces of small papers on it, and then take a pen and dip it again and again. When you will dip the pen, wave will produce. So these wave will move outward direction, but the paper will not move with the wave. Paper will just move up and down. It means that paper movement is showing the movement of water molecules only up and down energy, and the wave is moving forward. So if this kind of relation between particle and wave motion is that particle are only moving up and down and wave is moving forward, so this kind of relation is called transverse wave. So whenever we are going to define the transverse wave, we will say it is a mechanical wave in which particle move perpendicular to the wave motion. The velocity of wave is forward and velocity of the particle is only up and down. When this condition prevails, a sinusoidal wave is formed, and we call this is a transverse wave. So whenever someone asks you what is a transverse wave, a transverse wave is a mechanical wave, but this mechanical wave is such that in which particle only move up and down but wave moves forward. So this is a 90-degree relation between particle motion and wave motion. So this is the definition: a mechanical wave in which particle move perpendicular to the direction of the motion. Second thing, longitudinal wave. What is longitudinal wave? Longitudinal wave, the example is a sound wave. So how this wave move? This wave is not like the sinusoidal wave. It is like this compression and rarefaction. When someone is speaking and someone is listening, so whenever listener speaks, so the air molecule come closer to each other. When someone take a breath, molecules go away. In this way, wave, for example, I am speaking not from the laptop. When we are in the class, in the normal classroom, when I will speak, the air molecule will come closer to each other. When I will take a breath, so the molecule will go away. So the molecules are moving along the direction of the motion of the wave. So wave is moving from me to you, and molecule also moves sometime toward you, sometime toward me. So these molecules are always in the same direction or anti-direction. So you can say that mechanical wave in which particle of medium move parallel or anti-parallel to the direction of the wave is called longitudinal wave. You can also see this in the example of slinky spring. What is slinky spring? Slinky spring is a spring that produces the wave in the same direction. Or you can just imagine that there is a toy. Sometime you like the yo-yo. It's the rings. When you move the rings up and down, some rings gather to each other, some get expanded. So if you tie it from one end, another end is your hand, you move forward and backward, you can see some part of the slinky are close to each other, some are away from each other. So this type of motion, the wave will move from left to right, but the particles sometimes right to left, sometimes left to right, but these are not perpendicular, these are only parallel. So this kind of wave in which particle of the medium either parallel or anti-parallel to the direction of wave is called longitudinal mechanical wave. So we are also not discussing this one sound wave or longitudinal wave because this is next chapter. So we are just focused on the transverse waves. So as I told you, the transverse wave look like this wave in which particle of medium move up and down, and the wave propagation is from one point to another point. Let me draw this transverse wave here. When I'm going to draw this transverse wave, now I will discuss some important feature of this transverse wave. This is the initial position of the transverse wave, actual position of the transverse wave. This is the actual position. When it is moving, the wave is produced and it is moving. So you can say that this is the transverse wave like this. So this is a transverse wave. In this transverse wave, first and very important definition is amplitude. What is amplitude? Amplitude is the distance from equilibrium position to the height, from here to here or from equilibrium position to the depth. Both will be same. It is denoted by A. So if I ask you what is amplitude, you just say that the distance between equilibrium position to extreme position, either upward or downward. And this upper portion of the wave, this one or the other on the other side, is called crest of the wave, and this below this line is called trough of the wave. Trough is the portion that is below the equilibrium line, and uh, crest is the portion that is above the equilibrium line. Now, this is the crest, trough, and amplitude. Second, very important definition is what we call the wavelength. If this is a wave, let's say this is a wave, and this is its equilibrium position, let's say. So what is wavelength? Wavelength mean distance of one wave. It can be calculated that if you start from this point to this point, one crust and one trough, so this one crust and one trough distance from here to here is called wavelength, and wavelength is denoted by this letter. We call it lambda. This is Greek letter lambda. Lambda is showing wavelength. Wavelength means how much long a wave is. There are three ways to represent lambda. One is I showed you that one crust and one trough combinedly called. Other way is start from one crust and at the other crust. This is also called lambda. So lambda can also be identified like this one. But there is another way that you can use from trough to trough. For example, if you want to start from here and at here, so this will also be the lambda. So easiest way is one crust and one trough combinedly called wavelength. There is another thing that we already know. What is frequency? Frequency is
1 over T.
number of waves in 1 second.
1
Frequency
over
is
2.
number of waves in 1 second. So
Waves over is
it is calculated in hertz. Period is opposite to frequency, and it is time to pass by one wave. So if there are 10 waves passing uh, in 10 seconds, so time will be 1 second for one wave. So it is same thing, only I just use the word wave before we use the word oscillations. So the definition is same as it was, but when we are going to find speed of the wave, you know, speed is equal to distance times divided by time. Distance of the wave is wavelength and time is t. So speed is equal to lambda over t. One formula. Also, you know that 1 over t is f. So you can say v is equal to frequency times lambda. From where I got this frequency? Because you know that frequency and period are reciprocal to each other. So when these are reciprocal to each other, 1 over t can be written as v is equal to.
how will
Yes,
replace with F with T.
I didn't replace f with t. I replaced f with 1 over t. You know that f is equal to 1 over t. So here lambda over t means v is equal to lambda times 1 over t. So rather writing 1 over t, what I wrote 1 over t is f. So you can write v is equal to lambda times f or f times lambda.
Okay.
Okay, and now this is all about the waves that we need to know. Quickly I will just revise from the slide that what we discussed now. There are few very important, first of all, this question I skip here. If you are able to see this question, you can see when it is a transverse wave, is the velocity of the wave moving along the rope in the same as the velocity of the particle of rope? You can see now particle are moving up and down, wave is moving forward, so it is perpendicular. Okay, this you have to keep it in your mind. Now there are some definitions like amplitude. Whenever you use the word crust, what is the meaning? The high points on the wave are called crust. This is crust, this is crust, this is crust. The low points are called trough. This is trough and this is trough. Amplitude is the maximum height of the crust or maximum depth of the trough. So amplitude is this height or this height or this height, or amplitude is this depth or this depth. The total swing from crust to trough is 2a. What does it mean? From this point to this depth or this point to this depth is 1a plus 1a, 2a. Then I told you a distance between two successive crusts is called wavelength, and it is denoted by letter lambda. You can see from crust to crust, from trough to trough, one crust and one trough. I told you three ways to write the wavelength. So this is denoted by lambda. You can see here this opposite to y is the lambda. Also down there it is written lambda. Now, a frequency is the number of crust or completed cycle that passes at a given point. Time period is equal to 1 over f, and the time elapsed between two successive crusts passing by the same point in the space. This is the question. Let me ask you, Jamal, what is the amplitude in this question? The figure is in front of you. What is the amplitude here?
Uh,
Amplitude is the distance from equilibrium to maximum height or maximum depth.
4.
4. Very good. Thank you. What will be the wavelength here? Khalid,
Yes, mister.
what will be the wavelength here?
Yes, mister.
Distance
Let me get
from one crust to other crust or one trough to other trough?
two.
2. Very good. So what will be the period?
Me
One.
also.
2 also. What is the frequency? 1 over 2.
Two, which is half.
So 1 over 2 means 0.5. So this is the how we can use this one.
Mister, but how we use hertz?
How you
How use 0.5 hertz? How? Which one you can use hertz
look.
for this
Period
one?
is 2 seconds. So 1 over 2 will become, because frequency is 1 over t.
Okay, okay.
Okay, so this will we do. Okay, now everybody quickly solve this question. It is not difficult.
15.
Who spoke?
Ahmad.
Ahmad. Okay. How Ahmad it is 15? We have been given by wavelength lambda and
The 15
frequency
times
3. So you know speed is equal to 5 times.
Mister, we use the T 1 over F.
Yes, T is 1 over F and F is 1 over T.
Yes.
Now for this one, lambda is 5, frequency is 3. You just multiply it, your answer is 15 meter per second.
second.